I would like thank you for starting the recording. Welcome everyone to Astro Cafe for April 20th. My name is Peter Jedicke. I live in London, Ontario, and that's where I am right now with my wife Diane, who's watching on another TV screen. I wasn't able to figure out how to change the picture on her computer, so you see my picture there as well. And I did Randy when Randy sent out the notice about tonight's meeting, he said that I am a member of London Center, which is true, but I am also a member of Victoria Center. So I still feel like I'm with my own crew here. I have, on the other hand, also invited some Londoners to watch in, and I know no one will mind that. We have Norm McCall, who's actually sitting in his backyard observatory right now. I'm told it's clear here. I hadn't looked out the window. I hadn't thought of doing that. And there's also Millie Norrie, who's not an RASC member, but she and her husband John are friends of ours. And we just had dinner with them yesterday and mentioned that we would be doing this. And they said they might like to pop in. So there they are. And is there anyone else who's new? I think I recognize all the other faces that I see. Kevin and Randy, is there anyone in the room who'd like to be introduced as a new person?
No, no, we're all old regulars.
Okay, and is there anyone online that's new? Like I say, I think I recognize everyone's name. Hello, Lauri. Hello, Joe. Okay. That's great. Okay, so what we have this evening as a presentation from Gil, who's in Tucson, and he's going to talk about the Large Binocular Telescope. And then Phil, who's in the room with you folks, is going to talk about the Artemis imagery. And then I have prepared a slideshow about the history of the Cronyn Observatory here at Western U in London. And then, as you may have just heard a few minutes ago, Randy and David also have asked to be put on the list. And of course, if anyone else has anything to share, you will be welcome to do that, either in the middle or at the end, whenever we kind of get along. Is there any questions before we start, or anything? Does anyone have anything that's so important it needs to be said right at the beginning? Okay, very
Good.
good. Sorry, I heard a voice.
The cookies are good.
Yes. Yes, saying before we started that I had promised to have cookies here myself, but I actually forgot all about doing that. It would have been probably better for me in any case. Okay, good. All right. Well, so our first presentation is about the Large Binocular Telescope. Let me introduce Gil Esquerdo. You see Gil on your screen there. Gil is sitting in his office at the Planetary Science Institute in Tucson, Arizona. Gil has been friends of the London Center since he spent a year in London back in the early 2000s, which is now 25 years ago, and time just flies by, but we've maintained our friendship all along. And I learned just in the last month or so that Gil has changed from his longtime position as an operator at the multiple no at the Mount Hopkins Observatory. I've forgotten the name of the telescope, but it was not the multiple mirror telescope. And Gil was an observer there for many years, and he's a very keen astronomer. He's told me some wonderful anecdotes about how he got interested in astronomy as a youngster growing up in not one of the bigger cities in Arizona. And so he spent pretty much his whole life living in Arizona and has gone to wonderful things like the Grand Canyon Star Party. He drives a little Mini with his asteroid number on the license plate, which is a really cool idea, much supported. And his telescope fits in the back, if I remember correctly.
Barely,
All right, so Gil,
barely.
The
before
passenger?
It's the only passenger. There's no room for anything else beyond it and
I
me.
I never thought to ask that. So Gil has just transferred over to the Large Binocular Telescope, which is pretty amazing piece of equipment. Those of you who've spent time in Arizona have probably heard of it, but I'll bet you there's a pretty good chance none of us have actually visited there other than Gil having been there to work. So Gil, I'd love to hear you talk about the LBT for the next little while.
That was sort of my plan. Knowing that I only had about 20 minutes, I figured, how do I compress everything that I sort of absorbed in the last 5 months doing this new job? And I went, nope, we're just going to do a virtual tour. So I also sort of planned this to give myself a little bit of time because I expect a parade of questions. So I did open up things a little bit just so I would have room to answer a few questions as they show up. So let me just go ahead and well, I'll back up here. Let's go to screen share so you can see what I'm showing you. I always forget where that lives. Right there. And we're going to do this. And we're then
It
going to,
works.
and then a little full screen action to make this happen. So here we go. So as Peter was saying, I just started the Large Binocular Telescope at the beginning of this year, and it was a bit of a change for me to go from operating a 1.2 meter aperture telescope to two 8.4 meter aperture telescopes. So it's been a big step, as you might imagine. And my joke to a lot of folks is, well, what's it been like? I said, it's been like drinking from a fire hose because there's been an awful lot to learn. Um, but again, I just wanted to mostly give a nice overview of the site, of the telescope, what it's like. Peter's already seen a bit of this when he was here over the winter. I sort of data dumped on him and all the friends and whatnot who are here in town anyways. But I figured this would be a really nice introduction for you all because it's one of these weird places that the observatory does do tours, but they're highly seasonal because the road is not easily passable in the winter. So the problem is you're all avoiding the worst of the snow by coming here in the winter. We're not open to the public in the winter. So when you're here in town and able to make a tour, you wouldn't be able to do it anyways. So I either recommend come in the summer and suffer through it, or I'll give you the next best thing. So the thing that I learned, oh, you little turkey, this is going to be one of these little problem children, aren't you? Let's try this again. Oh, you stinker. Oh, it's not going to let me do what I want to do. You turd. Ah, bummer. Let's see if I can make this work. So we'll navigate around this. What I'd never realized, and on my first drive up to the observatory, and this was basically what I was presented with, is just the scale of this. Um, this building is 10 stories tall. There's the little Jeep that I drove up sitting there, and I'm looking up at the road. You can see the parking lot above it. Um, it's the size of a house, but it moves. So when you're looking at this building here, there's two parts. There's the fixed structure, which is the darker green, and the lower section, there's sort of circular part, and then the rotating structure. And the rotating structure is the silvery part up above. And the rotating structure weighs in at 2,400 tons, and sits on these four gigantic bogies that are basically the size of a van, but they're on train tracks. And so the building is sort of slave to the telescope. So as the telescope moves in azimuth, the building follows it along. And then, of course, the telescope itself can move in altitude inside the structure. What you don't really see from here is the shutters are facing away from us. You can't really tell what side opens, what doesn't. It's actually on the other side of the building. These four looks like a giant cannon pointed out the sides. That's a vent port that's about 2 meters across. And that basically ventilates the layer of the building just below the observing floor level of the telescope. Um, yeah, I have to do this the hard way. Bummer. We'll make this work. It's called workaround. Um, Unfortunately, it's tough to get a really good picture of the telescope that shows scale. The building is not much bigger than the telescope itself for obvious reasons. You don't want to ventilate a gigantic building that you're not occupying. So there's only a couple pictures here that show scale. But there I am actually on the telescope structure. That mirror is 8.4 meters across. There are two of them, as the name might indicate. And what you really don't see from this frame is on the other side, hiding behind all that structure behind me, is the other telescope. And they are co-mounted physically on the same structure. So as the telescope moves, both mirrors are going the same place. So it's a very different than what you're used to thinking of when you think of a telescope, even a large telescope. Again, simply because you've got this enormous structure, and how do you hold all this in place and make it work? Um, Again, I'm gonna have a tough time with this. Sorry, gang. I thought I demoed this, but didn't demo it while I was actually on Zoom. Um, so the telescope itself is quite remarkable. Uh, when you Whenever you see a picture of, say, the 200 inch, the 5 meter at Palomar, or the 4 meter on Kitt Peak, you see this very large, shiny structure that it sits upon. And those telescopes, they're actually sitting on oil pads, and the pressure turns up, and the whole telescope floats on these oil pads. And the Large Binocular Telescope is the same way. So when you look at this picture, you see that large, shiny surface sitting there, kind of aimed right at us. That's one of the two bearing surfaces the telescope is sitting on. So it's sitting down near the bottom. That's actually the pads that it's sitting on. And then the telescope can move in altitude this way on those giant pads. See, I should have demoed all this. Um, what you really don't get a sense of, though, is how deep those primary mirrors are. So a bunch of amateur astronomers, you all understand F numbers. That primary mirror is F 1.125. So it's a very, very fast optical system. And in all the pictures I've taken, I cannot get one that really shows how deep the bowl of that mirror is when you're standing next to it. I joke it's almost like a giant bird bath, just incredibly deep. What you really get a sense for here, though, this is looking all the way up. And so at the very top of the photo there, you see the secondary mirror of the telescope. And what you're noticing is that it doesn't have the normal cross truss structure to hold a secondary mirror like we're used to. What the telescope actually uses, we call them swing arms. And they're these giant sort of A-frame structures that can move in and out of the optical path of the telescope. So the telescope is almost infinitely convertible. So one of the interesting things with the optical design of the LBT is it is not what you're used to thinking of when you think of a telescope. You think of a Cassegrain design. The LBT is actually a Gregorian. So the primary mirror brings the light to a focus. The light actually comes and hits a concave secondary mirror, and then would come through a hole in the primary mirror. That is one of the modes that we can observe into the LBT, but what we do with that telescope is what's called a bent Gregorian. And we actually put a tertiary mirror in the optical path above the hole. So we can put the light all the way through down the bottom, put an instrument at the back, or we can kick the light out the side and have an array of instruments over there. And it turns out the bent Gregorian mode is the one that we use the most often. So here's another photograph. It shows the end of one of these swing arms. I'm again right at the level of the primary mirror. You get a little better sense for the depth of the bowl in it, but we're looking right at what we call M3, or the tertiary mirror. And that is the one that kicks the light out the side to the bent Gregorian mode. So basically those other ports where the other instruments are located. Um, in those, in that bent Gregorian situation, you can sort of see that tertiary mirror on the far right-hand side of the frame here, and you see all of these instrument ports that are aimed right at us. So one of the nice things is all of our instruments are always mounted. There's an instrument at Gregorian focus, basically down at the bottom. That's one. Here at this port, there are 4 different instruments that I can command from the control room. So if in the middle of the night, the observer says, I want to observe with Lucy rather than Pepsi, I can, with a handful of keystrokes, basically tell the computers, this is now the instrument that we're using. The mirror will move and pivot. There'll be a small alignment that I'll have to do. And then I hand the instrument off to the observers. So in the middle of the night, one of the great flexibilities of this telescope is I can change from any instrument combination that the observers may want and do that in as short as 5 minutes or as long as 15 if there's a bunch of swing arm changes necessary. There's a mode where we can observe 2 different instruments. So my other joke with the LBT is you remember the line from Contact after the first machine was destroyed, and Haddon basically was telling Ellie Arroway, why build one when you can build 2 for twice the price? That is the Large Binocular Telescope, because every single instrument that's on the telescope has effectively an identical twin. So each instrument that's on this central gallery, and I'll show you a better example of that in a second, has a twin. And it may not be identical. Many cases will have an instrument that is um, designed to work better in the bluer portion of the spectrum versus the red portion. So you'll have the same instrument, but one's a little more blue sensitive, one's a little more red sensitive. And again, depending on the science the observers want to do, will dictate which instrument the light's being fed into. In this central turret, in through here, one of the great powers of this telescope, and it's unfortunately underused at this time, is the interferometer, where we actually take the light from both mirrors, combine the light in one place, and can use that as an interferometer to get higher resolution data out of the telescope than you would with just a single mirror. So here's a view of the telescope pointed over at the horizon. And again, it's a case where you've got this thing shoehorned into this building. So I can't get far enough away to really show it off, but you can see the top end of the structure staring right at us. You can see the top of the two primary mirrors on either side there. And then there's a big space in the middle. And that space in the middle we call the gallery, and that's where all the instruments are located. And so again, if you've got the interferometer, the light's coming in, there's a beam combiner, and that instrument is right in the center, or you go ever so slightly off one to the other to get to those other instruments that are again held in that gallery. The keen-eyed amateur astronomers of you may notice on the left-hand side, yes, that is a C14 on a Paramount, and that is our seeing monitor. So what would be an instrument that pretty much anyone would absolutely love to have in their own home observatory? We're just using it as a seeing monitor. So it just gives you a sense for how ridiculous and oversized all of this is. Again, unfortunately, it's tough to really get a sense of scale. This is a case where we had the scope tipped over on its side, like you just saw in that previous picture. And there are three of my coworkers basically getting ready to go onto the structure of the telescope to look at something. So I figured this was a nice photo to sort of show off and demonstrate just a little tiny bit of what the scale is like. But my first take when I got in the building was just how massive all of this really is. So where do I drive all this from? Here is my control room. When the observatory was originally put together, at the very early aughts, the let me step back quick. My position there is it's called the operational I say operational specialist observer. And the idea basically is that the telescope is so complicated, I can't do everything. I can't operate the telescope and the instrument and decide science targets and keep up with quality control. I'm only responsible for the health and well-being of the telescope. In a normal observing situation, historically, each of these stations might have a person or two at them. You've got one person controlling the instrument. You've got one person controlling our adaptive optics system. Now, thank you, Zoom, as we can see right now, it's uncommon for me to have someone else in the control room. So this is left over, just the size of it is left over from 20 years ago. But the big screen at the far end that's off in this particular photo, that's the Zoom session that we have open to the remote observer. And they're actually controlling the instrument and telling the telescope exactly where to go. My job is to make sure that they don't do anything dumb. A quick view out the window in the afternoon, but here's a better look at what I'm staring at on a typical night. So again, everything is doubled, and we sort of split the screen in the middle. So the left-hand telescope's on the left-hand side, the right-hand telescope's on the right-hand side. You see the big rainbow color-coded plots there in the bottom. We are actively pushing and pulling on those primary mirrors to keep them in shape. And so I'm seeing how much forces are being applied to those mirrors live. I can actually watch that and make sure that there aren't too many bending modes that are being over applied and the things being stressed too much. The mirrors safe themselves, so if they do get out of control, it will kill all of the forces applied to it and put it back at rest. But I'm watching, again, all of these displays and all these numbers that you see here, watching them in real time and seeing how those are going. As amateur astronomers, we know our least favorite thing to do is collimation. The telescope has wavefront sensors on it. So you see the little grid patterns near the top. We are actively pulling a little bit of light from each telescope and measuring the views coming out of the optics and see how much of those bending forces we have to apply to the mirrors. So we are constantly collimating and focusing the telescope while we're observing. It does it on its own. It's remarkable sort of watching when I get on a new target, the telescope gets settled, takes a minute or two, and I can watch those final bending moments get put in play, and I can see those adjustments that get applied, and the images improve. I can watch that in real time, and then they snap into place, and I hand it off to the observer saying the telescope is yours. And just watching them constantly keep up throughout the night is kind of remarkable. So the real big thing, though, most of what we wind up doing with that telescope is spectroscopy. I've long joked that a picture is worth 1,000 words, but for an astronomer, a spectrum is worth 1,000 pictures. But no one looks at a spectrum because they're really not that pretty. So I thought I would show off some of the more recent pretty photos out of the telescope. So this is no processing, nothing fancy. At the very top of the telescope, one of the things that I can put in is a prime focus camera, and it operates at f1.2. So if any of you have or have used Hyperstar, where you remove the secondary mirror from your Schmidt-Cassegrain and put that corrector lens and the camera in place, this is the world's biggest, fastest Hyperstar. Um, and it's a remarkable thing to see. These are just a 5-minute exposure. The one on the left is sort of a V band, so sort of a green filtered. The one on the right is I, so like a very far red. This particular scientist is monitoring nearby galaxies. This is M101, looking for pulsation modes in giant stars. And so once a month, they'll come in and take this suite of these amazing images, out of the telescope and sort of watching red giant stars in these galaxies change brightness over time. So again, this is it's a phone camera taking a picture of my monitor. But it's never a bad night when they've got the cameras running because you get a display like this. This was actually my first run. I was still in the middle of training at the time. We have an instrument called Shark. And for those of you who've done planetary imaging, where you've got the high-speed webcam and you pull images out, and you then use software to then, pick out the better one, stack it, process it. This is that, but turned up to 11 because there's adaptive optics running on this telescope, and they can then do very similar way. You take a video stack, you then process the data. This is a live, basically snapshot from the zoom screen, looking at a main belt asteroid called NISA. And so you see sort of the interface that the observers are using here. But on the right-hand side, that potato-looking thing, that's the live view of that asteroid. And over the course of about 6 hours, we watched it slowly tumble and turn and rotate while they sat on this and observed this object. This one just absolutely blows my mind. This is Europa. This is an image, again, using the sharks. This is a visible light image of Europa. And again, this is just me. I've peeled some images off of the zoom screen. This is 1 arcsecond across. So you're actually seeing surface details on a Galilean satellite with an 8-meter telescope. Again, what lets us do this, though, it's the power of the adaptive optics. You've got a mirror there that you can make corrections to hundreds of times a second, little tiny deformations of that mirror, the small secondary mirror, not the big primary, to basically undo the turbulence of Earth's atmosphere. And then this is a week-old new finding out of the telescope. This is the newly discovered lensed quasar. So when you look at this image, this is in the infrared. So JH and K, so just a little bit further red than what the human eye can see. The zoomed in view, the G is the lensing quasar, even though they say G. And then the A, B, C, and D, the 4 elements, that's basically the gravity of that quasar. I'm sorry, of that galaxy and galaxy cluster is bending the light of this background quasar and making 4 separate images of the one lensed object. So there are some fun things that we're already seeing, that I am in just, a few months into this, that working with a multimeter modern telescope is quite a remarkable thing. Again, the view doesn't suck. This is from the roof. This was a night where we had some storm system come through, and the clouds deck was just settling. The LBT is not the only telescope on site. sort of just right of center there, there's the SMT, so a sub-millimeter, basically microwave radio dish. And then behind that little tiny dome is the 1.8 meter Vatican Advanced Technology Telescope, which was the first telescope on site. There was a large wildfire that came across the site in 2017. So what you're seeing is all of the burnt trees that were sort of victims from that fire. But if it weren't for the observatory, all those trees would be gone. There was a lot of active firefighting to make sure the observatory stayed safe. And then again, this was sort of my last night of my last shift on the mountain. That sort of shadow cone you see in the background there, that is the shadow of Mount Graham being cast on the horizon below. The SMT there is to the right, and then the sort of dead center. So that's been a sort of a speed view of what the LBT sort of looks like and some of what we do. Ran a little bit longer than I would have liked to. But I just, again, Peter asked me, hey, do you want to tell him about the LBT? And I said, absolutely.
Well, thank you very much, Gil. I hadn't seen your presentation before, and I haven't been up there, so I learned a lot too. And I hope
Brilliant.
everybody else got something out of that. Of course, we are open for some questions. Does anybody have a question in the room? Randy yeah, go ahead. You want to?
So you don't have a spider holding up your secondary. So what are the diffraction points like?
So it's a complicated enough structure that you don't really notice them that much. That they sort of blend themselves out, but also we're an Altaz telescope. So as you're sitting there and you're slowly tracking across the sky, those kind of rotate. So the cameras have rotators to undo the rotation in the sky that you would see with an Altaz. So in a very brief exposure, you might notice them, but over a longer exposure, you really don't see them. Again, so they do sort of get blurred out a little bit.
Well, that seems very clever. Why don't we do that more often?
It's a tricky thing to manage. I do know there was a paper that I saw maybe 15, 20 years ago, that someone actually created a mask that they put over their spider veins that sort of undoes the diffraction. And for my Dobsonian telescope, I had a friend of mine 3D print them. And it's amazing because if you look at something like, I want to look at the companion of Sirius with my telescope, those blow out the spider veins where you don't see them, and so you can actually get pretty close to an object. So I don't think we've done that with the LBT. It's just that the shape of that structure is such that it doesn't produce a really distinct spider structure like we're used to seeing.
Gil, I think in amateur, I sort of recall something called a single stock secondary,
Mhm.
where it's just a single wire almost thing would suspend the secondary. So maybe it has been done.
It's entirely possible, yes.
Yeah.
And again, these are massive structures that we're moving in and out of place. For an amateur secondary mirror, it's quite easy to do. So you're exactly right with that. The other trick, though, is that also a lot of amateurs will do a bent spider vein, and that will sort of also blur out the diffraction spikes. You don't see a spike. It sort of throws that light everywhere. So you lose a tiny bit of contrast, but you don't have that sharp spike anymore.
I see Gary's hand up. Gary, can you ask your question?
Yes, indeedy. My camera's not working, but that doesn't matter. So you mentioned optical interferometry. If I recall correctly, when I used to work up at DAO here, the astronomers were talking about at Keck, they had a heck of a time getting their optical interferometry going on the tunnel between the two scopes.
Hmm.
So was your telescope designed with optical interferometry in mind, or what, and how is it working now?
It was designed that way. So you think of like the CACs, they're two separate buildings, and you have to bring the light to them. You go back to, let me find that. There's a photo that'll show this, probably the best. And I think it's this guy. Um, these are now, they're co-mounted, they're on the same structure. And so when you have your interferometry optics in the middle here, they're fixed, they're not moving, and they are co-mounted with the same telescope. So if you think of CAC, you have to bring the light to it in a separate building. So this is a bit easier because, again, everything's sort of fixed together. I will say at the LBT, the interferometer is not used a ton. In my half a dozen shifts now, we've only used it twice. So there are some very specific projects that want to use it. I know that one of the instruments that uses the interferometer is actually in the middle of being repaired. So it's entirely possible that once those repairs are finished, the amount that I see it will go up. But the idea was, yes, this was designed sort of not as an exclusive thing, but the idea is that with the interferometry, it's easier to do because they're co-mounted.
Now you would get with interferometry, you'd get a higher definition, theoretically, right? Did that ever happen actually?
They have, absolutely. And one of the projects that they've told me they do with the interferometer actually is they can identify individual volcanoes on Io.
Oh
And so
no.
let's say you want to take a spectrum of one single volcano, you can do that. So
Wow.
I can't wait to see that for myself, but I'm like, okay, that's kind of special. I do know that to make this work though, your best resolution, of course, is in the long axis, between the two mirrors. If you want a more three-dimensional, not three-dimensional, but like a larger two-dimensional view, you actually need to observe the object for a very long time. So you get an observation at this azimuth or this axis, this axis, this axis, and this axis, and then put
Yes.
those together.
Okay, good. Thank you.
You're welcome.
Lauri, your hand is up.
Hi, yeah, I'm sorry, I missed something at the beginning. Where is the telescope exactly?
So the large binocular, actually, and I didn't say that, it was sort of my fault. So thank you for bringing that up. This is on Mount Graham, which is located on it's located just outside of the small town of Safford, and it's in the southeastern part of Arizona. So it's about a 2-hour drive to the town of Safford from Tucson, and it takes me a little over 3 hours to get to the observatory from here.
Okay,
It's an
thank
hour
you.
drive up the mountain.
Oh, that would be long. Yeah,
I
okay.
mean, so thankfully, so my shift is nice. It's 7 nights on. So when I'm up there, I'm up there. They have a nice dorm built into the facility. It's a case that if I wanted to, I could go from my room to the kitchen and then to the control room and probably never get on my pajamas if I felt like it. Yeah, if I didn't have to go upstairs to the building or outside, I could get away with that. They might wonder why, but I could actually do that.
Too much information, Gil. There we
It's
go.
just PJs. It's just pajamas.
It's
How many
Next
unique.
slide.
people, how many people are up there during your 7 days?
So we have a total day staff of about 80 people. Now they're not all on site at the same time. Most of them are based in Safford. During the day, I wind up missing most of the day crew. By the time I get to sleep, I might see a few of them. I officially hand the telescope over to them saying, you guys do what you need to do. And there's an official handover to me in the evening. But by the time I'm up and functioning, they're mostly done with their work for the day and they're getting ready to leave the mountain. Um, but it's a situation that because we are so far from any civilization, we have a 3-person minimum on the site. So if there is not 2 other people there with me, I can't open the telescope. And the reason for that is you need, let's say someone is incapacitated, you need someone to do CPR or whatnot, and so one person to drive. And so it's a 3-person minimum for me to be able to open the telescope.
That's really great, Gil. Thank you. Are there any other questions in the room?
What's the elevation of the telescope?
We are at 3,200 meters. So it's one of those cases I have to be a little careful my first night or two up there. I don't go bolting upstairs for obvious reasons, so I don't go, run out of gas. But yeah, we're up there quite a ways.
Is that higher than the top of Mount Lemmon?
It is by about probably 300 meters. Somewhere in that neighborhood, something like 300 meters more, 350, something like that.
With an incredibly fast scope like that, what's the length of your exposures and what sort of magnitude saturates the image?
The saturation I don't know offhand, but this is a 5-minute exposure. So this M101 in 5 minutes, and it's better than any picture I ever took as an amateur. But I mean, you can already see that a lot of these stars are already saturated and blown out. But again, we're also looking through specific scientific filters, so it's not a big broadband. You're not seeing all of the light, as you can imagine. But yeah, it's amazing how faint we can go and how quickly we can do that. I would guess that the faintest stars in these images that you probably can't see in this photo are probably 22nd magnitude, maybe 23rd in 5 minutes.
Oh, one last question. In the summer, it gets really warm there. How do you cool down the optics in the day so you're ready to go at night?
So one of those plots that I had here, so the big rainbow color ones, that's actually the forces that are on the mirror. The one above that, we are actively forcing cool air. So this is one of the Mirror Lab mirrors from the Steward Lab here in Tucson. And so it's hollow. And there's these big hexagonal cells that are, there's nothing but air in there. Our actuators are actually pushing her in there, but we've got all this empty space. And so we actually actively force air up into those cells to keep the glass as close to ambient temperature as possible. And so when you see those two plots, the green outer portion of those is what ambient temperature is. And then it's showing me the temperature sensors that are reading the glass temperature. And you can see in this particular case, things are pretty close. There are a couple little patches that are reading a hint high. And again, some of those sensors are bouncing a little bit. But one of the control boxes here, in fact, the one just above the mirror control, is where I can set the temperature. And so during the course of the night, there's basically an automatic mode. And I say, you chase ambient. And so we are actively forcing cool air, or if need be, warm air into the back of the mirror to get it as close to ambient temperature as possible.
Wow. Okay, thank you very much, Gil. Please
My pleasure.
unshare your screen.
I will do that right now.
And now it gives me pleasure to introduce Phil Stooke, who most of you know. He's been in Victoria for more than a few years now, but he was in London before that. Phil was a member of a faculty member in the, I hope I'm right about this, Phil, the geography department at Western U.
Yeah.
And his expertise has always been in analyzing images and surfaces of objects in our solar system that are not the Earth. And so Phil has prepared something about the Artemis imagery. Phil, are you ready? Shall I share now?
Yeah, that would be great. Thank you. Peter's going to advance the slides for me here.
Okay. Did that work?
Looks good.
Did
Okay.
did we get to the start of the?
Yeah, go to the.
Can everybody see the first slide?
Excellent. Okay, thank you. Yeah, good. And Randy's just moved the microphone a bit closer to me here. Thank you, Randy. Yeah, so I want to look at some Artemis 2 images, and I'm not going to look at many of them, just a few specific ones that I wanted to say something about. But if we just take a look at this first one, very familiar. There's the large dark area in the upper right is the Ocean of Storms, Oceanus Procellarum. And then there's that sort of bullseye pattern a little bit below the center and separate from the main dark area. That's the Mare Orientale, the Eastern Sea. We were talking about it last week, and Randy was wondering why it's called the Eastern Sea when it's on the western limb. But I decided that we'll call it the Eastern Sea because it's on the eastern side of the far side of the moon.
There you go.
There you go. Okay, so there are a few things I want to talk about in this area. One of them is the little smudge that is just below Mare Orientale there. And we're going to zoom in and have a look at that. But let's go to the next slide first. These Artemis images, of course, not the first ones of this area. The first pictures of that area that were ever seen were taken in 1965 by the Soviet Union spacecraft Zond 3. Zond 3 was a Mars probe, which was not ready in time for the launch window to Mars. And so they decided to use it to take some pictures of the far side of the moon, filling in a gap that had not been seen in 1959 by Lunar 3. So it flew past the moon and it took some pictures. And these pictures were taken on film, developed on the spacecraft, and then scanned, and the data transmitted back to Earth, as all of the early Soviet images were, and as the American Lunar Orbiter spacecraft did too. Okay, so there you can see Mare Orientale, the Ocean of Storms, Oceanus Procellarum there. And just on the sort of southwest side of Mare Orientale is this little ring, which we're going to look at. That right there, yes, that's right. Oh, this is great, Peter. It's pointing at things. Okay, so let's go to the next picture. The next slide. Here we are. And so this is a mosaic of the Zond 3 images of the far side. Now the ocean of storms is over the limb, so we're looking mostly at the far side in this view. And you can see lots of craters, as we'd expect on the far side. But there's the Eastern Sea, Mare Orientale again, and that dark ring below it. And the Soviets made a map of this area, and they assigned names to some of the features. So let's go and have a look at the next slide. And this just shows some of those names. On the left here, we've got the Lunar 3 images, the first images ever taken of the far side. And on the right, we see the area covered by the Zond 3 images in 1965, and a few names that have been given. And what I want to focus on here is the thing that is down in the bottom right-hand corner that they call More Mirno, which means the peaceful sea. Mare Pacificus, it was sometimes called, the peaceful sea. So let's go to the next picture now. Now we're looking at an Artemis 2 image. And there's Mare Orientale, the big bullseye pattern. And this dark ring, which is More Mirno, the peaceful sea, down below it. Now, it's not a typical sea in the sense of the lava flow, like all of the other seas and the oceans of the moon. It's just a volcanic ash deposit. And it's been erupted out of a vent at the center of that circle. And we can just about see it there as a tiny little spot. But let's go to the next picture where we'll see it more closely. This is another Artemis 2 image. You can see the dark ring. It's just kind of plastered on the landscape. It's volcanic ash that's been erupted out of that elongated vent right at the center of the ring. There it is. Yeah. And it erupts upwards and then out and falls down in a circle around the vent. And I don't know if that might remind us of anything, but let's go to the next slide. Here.
Oh,
Yes, it's Io. And Io has lots of these central vent eruptions showing up as bright rings here. You can see several of them in this view.
that's great.
This is a Galileo image. Io has lots of these things. The moon has one, and it's the one that we've just been looking at. On Io, the bright ring is sulfur and sulfur compounds erupted out of the volcano and condensing on the surface around them. And on the moon, it's volcanic ash, basically basalt, lava ash. So it's they're made of different things, but the process is the same. And now let's go to the next slide. And here we can see on the left-hand side, you've got that picture of that sort of umbrella-shaped plume, which is erupting out of a central vent and then falling in a ring around it. And at the top, there's several pictures making a little movie showing material moving in that plume. These pictures were taken by New Horizons, the spacecraft that was on its way to Pluto, flew past Jupiter and took lots of pictures of the moons, including these great pictures. So Io has lots of them. The moon has only one. And let's go back and look at this thing again. The next slide. There it is, with its vent in the center. Now, I say there's only one. There's only one that we can see as a ring deposit like that. There might have been others. But if there were, they've been covered up by the vast lava flows of the lunar seas. So Artemis gave us a very, very nice view of this rather unique feature on the moon. Okay, now let's go to the next slide. And now we'll deal with something else. Here are these great crater chains, or catenae, which again Randy mentioned last week. They're formed when huge blocks of material are thrown out of this massive impact basin, crash down to the surface, and each one makes its own crater like that. And these long crater chains form as a result. Now, they're quite common around lunar craters, but on a much smaller scale in most cases. These are by far the biggest and best developed on the entire lunar surface. But let's go to the next picture.
Yes.
Yeah, so
The Mare Orientale, is it radially symmetric? Do we see these on the near side also?
yes, but not. But they're older than the Oceanus Procellarum lavas, so they're buried.
Mare Orientale is older than the Oceanus.
Oh yeah.
No, I thought Mare Orientale was the last one.
It was, but the lavas came later. But there are on the south side of the basin, but on the near side of the moon, there are long valleys called like Valles Inghirami, Valles Bouvard, I think, two of them, which are really just crater chains of coalescing craters like that, but they're not quite as separate craters that make those nice chains. Anyway, this is just examples of several crater chains near Copernicus to show that these things do happen in other places, but on a much smaller scale. Okay, now let's go to the next slide, and we'll go back to Zond 3 again. So this is that map that was made out of the Zond 3 images. And we can see a few named craters. For instance, there's one called Kibalchich there, which we now call Hertzsprung. So these are the old Soviet names. The only one that is actually retained in the same place is Korolev, named after Sergei Korolev, the chief designer of the Soviet lunar program. Okay, so the features that we want to look at, they're hard to make out on this. They're better on the original. But they're the things that are labeled with kind of slanting text labels on the right-hand side. GDL, GIRD, RNI. The Soviets named the crater chains after their space research institutions. Let's go to the next slide now, and we'll see a modern lunar reconnaissance orbiter mosaic. Oh no, this is actually an Artemis 2 image. So Artemis 2 image of those crater chains blown up a bit. So you can see the crater chains with the modern names. And the modern names are Catena Leuschner, Catena Michelson, and Catena Lucretius. But they also, as additional official names, are those Soviet designations, GDL, GIRD, RNII, which are named for those research laboratories that are named on the left-hand side there. These crater chains have quite a long history of observation, and they commemorate some of the groups that did the basic research to produce the first rockets that could launch anything into orbit.
Can I ask a question, please?
Oh yeah, sorry, yes, absolutely.
So I'm looking at those crater chains, and they look awfully uniform between them. Now, this may be a dumb question, but is that something actually really separately spaced or uniformly coming down from above? Or could it possibly be something bouncing along the surface of the moon?
Bouncing doesn't work, but it's just too difficult to make it happen physically. But what is thought to happen is that an enormous block, you could think of something, like the size of a huge mountain that has been pushed up and breaks up in flight. And this object that is broken up in flight then falls down as a series of things. That perhaps accounts for it. Bouncing is physically, you can't make it work. People have tried to argue that, but it can't be made to work physically.
Fair enough.
Okay, let's go to the next thing now. Yeah, so now I want to look at one of the pictures that was taken during eclipse. So the crew in the Artemis 2 are in eclipse. For much of the time in eclipse, they wouldn't really see anything at the dark limb. But as the sun gets closer, just before the sun will rise above that limb, you get a glow, which is some mixture of the corona and zodiacal light. It's not quite clear exactly what the combination is that we're seeing there. But there are also visible streamers. There you can see a couple of fairly bright streamers there. When I applied a high-pass filter to this, we'll go to the next slide, you can see quite a bit more structure. And of course, the light and dark band along the limb is an artifact of the high-pass filter. But this shows us those streamers quite nicely. And it recalled to me the fact that Gene Cernan, orbiting the moon in Apollo 17, saw things like this, and he made sketches of them. So let's go to the next slide.
Is that the sun, or is that off the surface feature of the moon?
Well, the moon is just the black silhouette. So those are features in the corona of the sun.
But it has a surface texture. So, but it is off the sun.
Yes,
Okay.
right. Yeah, Cernan drew these rays, streamers like this. Well, that's a picture of Gene right there. He's actually in the lunar module in that picture. Very grubby after having worked on the moon for 3 days. And I think he looks quite exhausted in that view as well. But when he's back in orbit, and it takes some time to do these orbital observations, he made these sketches. And at the time, they were interpreted as dust streamers. Dust levitated off the lunar surface by electrostatic forces, and somehow, and it wasn't really quite clear how this would happen, but somehow ejected in streamers several hundred kilometers up. I think physically it's rather difficult to make that happen. But for a long time, people thought that this was dust that he was seeing. And a spacecraft called Laddie was put in orbit around the moon, a very low orbit, specifically to detect this levitated dust. And it didn't find any. We don't believe that they actually are dust. So it seems most likely that Cernan was actually seeing structures in the corona. I think some people thought that at the time, but it wasn't the prevailing view. But now it seems most likely that that was indeed what he was seeing, coronal streamers. Now let's go to the next picture. There's a nice crescent view showing the dark, smooth dark plane at the top is Mare Serenitatis, right there. Yeah. This is not the view that most of the Artemis images showed, but most of the things that were released earlier were taken during the approach to the moon and then zipping around the far side. But now that the crew are back, more images are being released. And so this was just released a few days ago, showing the view as they depart from the moon. And so it's actually worth checking back on the Artemis 2 website to look for new images, because they're still coming out. Okay, can we go to the next picture now, please? All right, so this is the final one. I just wanted to say that in about 6 months, there will be a preliminary science report on the mission. A first look at the what the images tell us and what the crew observations tell us, including about subtle color variations on the surface and things like that, as well as their observations of the corona and that sort of thing. So we'll get some more results in about 6 months and maybe say something about it then. And yes, that's the end.
Thank you very much, Phil.
Okay.
It's up to me to stop sharing. Give me a moment there. Okay, that's great. Now I'm getting the view of the room again.
Right.
And I have to click the, okay, yeah. So are there any questions, folks? I don't think I see any hands up on the online group. Oh, but I do see a hand up in the room there at the back. I'm sorry, I don't know your.
Regarding the volcanic ring,
Yeah.
Any estimate of the age of when that occurred, or can you do that?
It's there isn't really very much in that image to tell specifically, but it would almost certainly go back to the say sort of on the order of 3.8 billion years, 3.6 billion years, maybe something like that, around the time that mare lava flows were forming, and this is just a different kind of eruption.
Wow. Amazing. Wonderful.
So, Phil, you said that those Soviet missions, they used film, and you said that the US did the same thing. They must have lost a fair bit of resolution in that whole process, yes?
Well, okay, the thing is, how are you going to get the pictures back otherwise?
Well, yeah, of course. But
Yeah. Yeah, it wouldn't be ideal, but they had used a very high resolution densitometer to scan the negatives that are produced. Right, you take the picture on film, you develop it on board the spacecraft by running it between rollers with developing fluid in them, and then it goes through a scanner, a densitometer that basically is measuring the transparency of the negative. It was a very high resolution scanner. So they actually got really very high quality images back. And that digital data that came back was used to generate photo negatives on Earth, and then you could print from them. But the digital data wasn't really used because people didn't have computers that they could use very easily to work with that digital data. They were still in 1966, 67, working with photos. They're like photo interpretation, making photo mosaics and so on, all done manually. And it was only about 10 years ago that the old tapes were recovered and digitized, so we actually have the digital data now. And it's very good.
Pretty clever. And there's a whole story about that. Yes. The engineer who was told to dismantle everything took it to his garage.
Yeah, that's right.
And it was only saved because the last functioning machine was in this retired guy's garage.
Yeah, that's right.
That would make a really good astrocathode talk.
so wait a minute, Randy, you're saying that in the Soviet Union, there was an engineer who
No. That's JPL.
This is for the lunar orbiter images, the American
lunar orbiter, not for the Zond images.
No. No, not the Zond images. I don't believe that there is any digital data left from Lunar 3 and Zond 3. We only have the photographic products.
Wow. Okay. Well, any other questions? Anybody online there? Again, I'm not seeing any hands up, but that you're welcome to make a question if you like. Okay, not seeing any. So what I'd like to do, or I'd like to suggest, is that that your local presentation should come next, and leave me for the end. Randy, would you be prepared to talk about your puzzle? It might even be kind of appropriate, since it looked to me like it was that puzzle box looks like it has a picture of the moon on it.
Yeah. Is Brian here? Brian Barber? Maybe not.
No, I think he's away now.
Brian.
Okay. Anyway, so yes, I'm sure. Good.
Good. Okay. You're full screen now.
Yeah. So as everybody knows, I'm interested in the moon. Brian, I think, received this in the autumn, this puzzle, and put it together. And he said, it's a tough one, but then he said, but I thought as I was doing it that you'd be interested. And I like doing a puzzle, but this one looked really tough. But we do in our lunchroom at work, we usually have a puzzle set up and people kind of fool around with it. And they looked at this and said, you're crazy. because it's just shades of gray, and there are 1,000 pieces. And anyway, at the end of January, we finished another puzzle and we pulled it out. And Lordy. So let's just take a look at this time lapse. So that's February 3. Notice that we didn't actually finish the edge. Puzzle makers know that you want to finish the edge first, but that was not going to happen. And you can see we kind of separated the dark from the light. And to my shame, I was thinking, this is a very strange projection because the light was always radial, so that you could tell which way pieces were by seeing that the light part was pointing towards the outside. And I said, well, this is some fancy mosaic, because I don't know if people looking at the full moon, you don't actually have the contrast, at least with my 6-inch Newtonian, you don't actually see the contrast to see these craters very well. I find the full moon very frustrating to look at, because you're just looking at changes in albedo. You're looking at the dark mare, the light late craters. Very interesting story on the albedo, but there was something very strange with this. Anyway, here we are. That's like a month in. And he's getting there, 2 months in. And I'm amazed my colleagues put up with this, because it really was very difficult. It's my colleague Jen Lee who really got into it. And wow, getting there.
So
there's Tark Hamilton, another colleague who was very enthusiastic.
Randy, Randy, hang on for a second. What was the ending of that? You know, you mentioned about the way the light was shining.
Oh, I'll show you.
Oh, okay, all right. Because I'm not clear on how they did it then.
Okay, hold your breath. Excellent question, Peter.
Okay.
And then on the 16th, I actually put a notice around on the group chat saying we're going to finish it today. And there was about 5 of us. I should have brought the pictures. One of my colleagues took a picture of all of us around doing the last pieces, and Tark got to, okay, so yeah, so then where's the piece of edge? And so we went back to the box, and in the box was a bag, and the bag was closed with tape, you know, with masking tape, and that piece was stuck to the tape. So there it is on the left. On the right is a nice high resolution, high contrast picture of the moon. And the story is, you know, the sun is pointing straight at the middle of the moon. So we're getting what's called the specular or direct reflection off the middle of the moon. And then all the way around, we're seeing these craters on their sides, right? And so that's why we're seeing this radial pattern of the sun and the higher contrast as we see the rims of these craters are more, we call it normal to the moon, and we're getting the shadows on the mountains on the other side. So listen, I have looked at the moon a lot, and I never noticed that before. So it was really quite delightful. When I see it now, it's like, of course, everybody should know that. But I didn't. And so I'm really pleased to have done this. I have brought the puzzle into this room, and I am sure Brian would be delighted if anybody else wanted the challenge. And if you didn't like only do it for 5 minutes after lunch, it would take you less than 3 months to do it. That's my story.
Very good.
Thank you very much, Randy. That's quite entertaining, and I can just imagine what your coworkers must be thinking of you and hoping that hoping that you never bring another puzzle in and putting
Hi,
you on some
Randy.
kind of a blacklist saying, we like puzzles, but not from Randy or something like that.
No moods.
Hi, Randy.
Hi.
I did
Yeah,
that
go ahead.
puzzle myself.
You did. Congratulations.
Yes, but
How long did it take you?
It took me a long time, and it took me too long. But I resorted to a trick, and that's noticing that the puzzle pieces are radial.
Right.
And so you can no longer honor the one outie or innie bit per piece because the pieces have to get smaller as they get to the middle.
Right.
And if you sort the pieces as to whether they have one on each side or whether there's an innie and an outie, and you know the innies and outies alternate, you can actually put the puzzle together, not only looking at the shadows on the craters and the size of but also the shape of the piece itself. And I'm sure you appreciate this advice now that you've already completed the.
Well, I did. Hold on. I'm going to share another picture if it's okay. Let's, oh my goodness. Where am I? Zoom. And share. And share. Where did it go? I had the picture up. I really did. There it is. So I got interested. I'm going to blow this up a bit in the actual shape of the thing. Can I do that? Yeah. And so what you get with the orange, these are kind of spokes. Of course, I didn't see this until the end. You were clever to do it during the making. And then the green dots, if you can see them, they're these funny pieces that have an innie and an outie on the outside and just one on the, towards the middle. And they kind of do these funny radiating patterns around. Anyway, so the actual template of the pieces is very clever, but we didn't use that because we weren't that smart.
That's the only way I got it done.
That's pretty amazing.
Okay, unshare.
I'm not generally a puzzle person, but I find that really fascinating. Thank you. Any other
So
questions?
again, the box is here, and I'm sure Brian doesn't want to do it again.
I do have something very important to tell you folks in the room. I see that the box with the puzzle is sitting right next to the box with the cookies. Please don't eat the pieces of the puzzle.
Thank you. Okay,
All right.
also on the table here, I just want to show to the people here is I'll show it there too, is many copies of International Astronomy Day poster, and you're very encouraged to take a couple and put them in libraries or hotels or something. But we'll be talking about the International Astronomy Day soon.
Well, isn't that this coming Saturday?
That is this Saturday.
So do you want to say something about it now?
Who's going to be the spokesperson? Lauri?
Oh, no, I have something else to say first.
Go.
Okay.
I vote that we will pay for shipping of the puzzle to Peter.
Don't you dare.
Second.
Okay.
Okay,
Or
thanks very much.
you can go ahead, Randy, with it first, and then we'll chime in.
Okay, Saturday. Well, first of all, thanks to all the volunteers. It's been really wonderful. The kind of central coordinating group is Ben Spiller, David Lee, Lauri, Roche, and me. But I think there's probably 30 people on our volunteer list. That does not mean that we can't use your services if you can come. And also, it's a great way to get to know, if you're a newbie, what we do. And then we'll snag you to volunteer next year. So a couple of things. We're doing the regulars, the welcome desk, where we intend to hand out old magazines and the old RASC handbooks. They're excellent. So please bring old handbooks to distribute. I'm certainly bringing my last year's one there. But Lauri has gathered together a bunch of nice stuff that we don't want. And we're calling it a giveaway table. And I'm going to be on CFAX tomorrow at 8:20. And I'd love to say we've got this giveaway table. So what are some of the things that we're giving away? Because I think that's something that will really attract people who are listening to the radio.
Well, we have books that we have been that have been up at the center for a little while that belong to the RASC. We have books that actually have been in the cupboard at the center that have been sitting around for years. We've got magazines and we have posters so that we'll be giving away. We'll be people want to take away that kind of thing. Yeah, for sure. So that
what's the name of a book that I might be able to say on the radio?
I will get you a couple. I will get you a couple of some of the things. I'm going to be. There are some things that came from Sid's place that are actually quite good, and I'm not going to put them on the absolute giveaway table at all. But maybe at nighttime we're going to have a donation table. So that we can, because we can't ask for money at the museum, but we can put a donation box up at the center in the evening. And so if anybody is looking for something, I've got a couple of things that probably people might want that will be there. I will send you something tonight with some names. Okay,
that's great. And I just want to go through the speaker schedule. So let's just see. It'd probably go by memory, but I'm trying to find the. Yeah, that's not the right email.
It's on the poster, Randy.
Smarty pants. Okay, right. So we have Dennis Crabtree will be at 10:30. Photographic Legacy of the DAO and John Stanley Plaskett. Then it will be Chris Gaynor at 11:30. Artemis 2, Humanity's Return to the Moon. And Chris is also organizing a table just about Artemis. And that's going to be another thing that I think is a big draw, and I will be talking about on the radio tomorrow morning. I think that there's so much interest in this. And so thank you very much, Chris, for organizing that. And then Lauren Harrison, I believe she gave this talk at the Center of the Universe, is Women in Astronomy, Canada and Beyond. That'll be at 1:30. And then Megan Mraz at 1:30. Yes.
No, 12:30. 12:30 is Lauren's and 1:30 is Megan.
1:30 is Megan. the universe through the lens, a journey in capturing the night sky. And then at night, then it's John Willis who will be talking about his new book, The Pale Blue Data Point. So it's going to be just wonderful. Do contact any of the central committee if you're saying, that sounds like too much fun and I want to also be involved. You can be at every level of the hobby. There's nobody who should feel that they're not able to contribute. There.
Absolutely
So
not.
and my question for Peter is there any International Astronomy Day happening in your part of the world?
I was hoping you wouldn't ask because the answer, unfortunately, is no. And we
Yeah.
just don't have the kind of activity that you folks are blessed to have. And I wasn't going to mention it.
I'm sorry. I shouldn't have brought it up.
That's okay.
Actually, I know that Toronto is not doing it, and that is because they've lost the Ontario Science Centre. They used to have a really big event. I was talking to Kirsten Vanstone, who I'm giving a talk with her at the General Assembly the following weekend.
Right.
And Lauri, are you going to talk about the GA?
Sure.
Okay. So, but Kirsten was telling me that there's a real problem with the Toronto Centre because they've lost their venue. And it's sad. They had a really supportive organization that was hosting all of their events, and they don't have that now.
Well, remember there were quite a few years where we didn't have the partnership with the museum, and that did make a huge difference.
Yeah.
But Ontario has the gravy plane now.
Well,
Yeah.
Right.
So I just wanted to just give a couple of other little bits about Astronomy Day. On Friday afternoon, there's going to be a little group of us going up to the center to take any equipment and materials and resources and things that are at the center. And we're going to be taking it down to the museum. And anybody that would like to come down at about 4:30 to the museum to help set up tables and chairs and put things together a little bit, that would be wonderful. We've got a little team of about 6 of us going, but more would be lovely. Thank you. And we spend a little bit just getting everything ready for the morning. And then in the morning between 8 and 9, people are allowed to bring their cars if they have anything that needs to be brought right up to the back doors. We have a person who's going to be on duty to help the cars come right up to the back door and unload. And that's a fairly easy task to do. But then at 9 o'clock, unfortunately, they close that back to pedestrians. And so between 9 and 10, if you're bringing anything into the museum, then it has to be unloaded either out the front door or out the back door by the back parking lot. And then you'll have to go and park your cars somewhere else. And as I've said before, the parking is always a problem. And unfortunately, we don't have any really good spot for people to be. But there are lots around, and some parking on the street. If you're only going to be there for a couple of hours, then you might be able to be very lucky to find a couple of hours of parking spots on the street. But otherwise, we're leaving you to your own devices to do some parking. And so it starts at 10. We want to have everything up and ready to go. So if you are one of the leads of the table, or if you are one of the volunteers, we'd like to have everybody there at about 10 o'clock or so if you're doing a morning shift. And then we have different shifts during the day. I know some people are on for kind of 2 hours. Some are on for 3. It kind of just depends on what the leads wanted people to do. And then and then we'll just kind of continue all day through till about 3 o'clock. And then at 3, we start taking everything back down again. And we are not allowed to have the cars back up by the back door. So it takes a little bit of a village, but if everybody can just stick around enough, that people can kind of help take out some of the equipment that is for the solar telescopes. Bill Weir's got a lot of telescopes. We've got a lot monitors and things from the astrophotography table, like lots of things to kind of put together. And then we have to put the entire Clifford Carl Hall exactly back how it was at 4 o'clock in the afternoon on Friday. So everything has to be, completely taken down, put away, everything done. So anybody that can stay behind a little bit on the Saturday afternoon to do that would be really helpful as well. Are there any questions that people have that are either here online or in the room? I'm thinking that quite a lot of you are already doing some volunteering here for us. I can see you. Any other questions that people have about the day?
Lauri,
Yes.
I asked you today, but I don't think you had a chance to look at it. Do I bring my lunch?
Yes. Unfortunately, the cafe that used to be in the hall has gone, and so all that is left is your IMAX concession. So if you like hot dogs and popcorn, you've got it made. Okay. Otherwise, you're going to have to go out. The nearest place to actually buy anything is actually about a good block away, somewhere.
Don't they have food
No,
carts?
the food carts are gone too, David. So
okay.
they're really honestly, it's honestly kind of a little bit of a desert. Right in the middle there right now. So if you want to, I'll bring your lunch. I'm going to just bring some water. Bring a water bottle. There's water stations and stuff like that. We'll see if we can bring some cookies.
Yeah,
we
I'd
can
like
bring
that.
cookies. Yeah. So Natasha,
this is how you get your cookies.
Yeah. Natasha?
Yeah, you go there often, so I was surprised to hear that because I was told that the Sequoia Coffee is now operating that little place at the corner where the coffee shop used to be. It's got a menu and everything online.
There is absolutely nothing inside Clifford Carl Hall.
Okay, good. I'm glad you mentioned. I had been counting on that.
No, unfortunately, no, it's not. It's not there. That's really too bad if that's there, because there is literally nothing there. There's only the concession. That
Okay.
Yeah. You'd have to head out to Douglas Street. There's lots of places
Douglas Street to get
Douglas Street,
something, which would be fine. If you've got, if you want to go back out and have a look, but there isn't very much there. Yeah. Okay.
Okay.
David, is there anything else that you need from people?
I'm gonna talk about that in the next. That's maybe a really good segue.
Thank you, Lauri. Yeah, go ahead, David.
Okay. Before I talk about a report that I'm about to give, I will continue with the IAD stuff. So yeah, we're doing really well. We've got all our speakers lined up. One thing I've been trying to do is do some additional kind of advertising. So we have 2 video clips queued up. I'll have them ready for you, Joe, tomorrow morning. So there's one from Lauren Harrison and one from Chris Gaynor. So I'm hoping, Megan, you're on board. I'm hoping maybe, Megan, you might participate as well. But I'm not saying you have to, but it'd be nice if you could. So we'll be posting these on social media. We'll also have them on the website. Now, the additional thing, the real in-person kind of advertising that I would like to do is I'd like to do some sidewalk astronomy. So it looks like we're up for maybe a few clear nights and days coming up. So right now, tentatively, I'm thinking maybe Thursday evening, either at Cattle Point or maybe at Ogden Point, or maybe both. We could split the group up. But if we, yes.
How about in front of the museum?
I thought about that too, but Lauri said maybe at night that's not a great place. I don't know. What do you think?
Well, if there's not a lot of people that go by at 10 o'clock at night there. Like it really
Now,
does shut down a little bit.
if we have a daytime thing, we could have solar scopes out.
Absolutely.
We could do
Yes.
that.
That would be great. Yeah. And early evening would be probably fine.
Yeah.
But I wouldn't, there's hardly any traffic by the time you get to, 9:30, 10 o'clock.
Yeah. So anyways, I will announce through, I'm not sure which mechanism, but normally I communicate with the Cattle Point people through the Cattle Point distribution. But if I want to make it broader, maybe I do a different distribution. But anyways, you heard it here. Contact me if you want more information. And I'd really like to have some people out there on the pavement.
And please please, if everybody in the room takes one of the little posters and puts it up. I mean, all the different community centers we'll put something up. You can put them up at shopping centers, you can put them up at thrifty store, that kind of thing to get just a little bit of some media up around the edges. So the poster is also online, so you can
actually one little tip about the poster. There are 2 QR codes on the poster, and I wouldn't mind if people saved a little chunk and put it in their photo library on their phone, because if somebody asks you, you can just flash that. They could pick up the website right from the QR code. So that's a smart tip. So if you're out sidewalk astronomer kind of stuff doing, then take your little snap of the QR code. Okay. No more questions. I'll just move on to my second update. Now, as you all know, poor Sid, we lost Sid Sedun late last year, and we've been in the process of going through his garage and an observatory. Now, Sid was our director of telescopes, and wow, did he collect a lot of telescopes? So just a sec here. I'm just gonna share like a before picture and then what we have as of the end of this weekend. Okay, so many of you may recall this. Well, maybe I'll just start from here. You may recall this presentation uh, near the beginning of the year in February. So that's when we really started this whole thing about going up to Sid's place and starting to build an asset inventory, because we didn't know how we were going to approach this. So anyways, we started cataloging everything. So there were quite a number of different types of telescopes. Some of them maybe not so great. Probably about 30% were quite good, actually. So this is us. This is back in February. There's Lauri. There's a bunch of people out here. There's Jill. All kind of looking at all the stuff that came out of Sid's garage. So this isn't the garage in February in its entirety. This was almost totally blocked in. Sid's son actually cleared the pathway for us here. And in the side room, there was a lot of telescope making equipment, like all sorts of abrasives. And for those of you who are longer in the tooth than even me, probably remember making mirrors and things like that. So I did start making up this kind of catalog at the time. When I started it, we had only 24 items. The next session saw that bump up to 50 items. And then some of these items became like collections of objects, like full rigs of telescopes. So Brock had this brilliant idea of trying to assemble some of these things rather than just catalog of a whole bunch of little parts. So that was an excellent suggestion, and probably was an aid in doing what happened this weekend. So we knew that we wanted to sort of build up these functional units, and let me just go over here. So after all that, Much less. Much less. And there's not even much behind this either.
No.
So you can imagine this whole garage was full, plus the side room, which had all the telescope equipment. Thank you to everybody who came this weekend. And a big thanks to you, Vince, for taking the stuff that I didn't think we could get rid of, which was the telescope making equipment. But some of that went. Those C8s, I thought we had a farm of C8s. Reg, we can no longer build that large bank of telescopes. Those C8s are pretty well gone. A lot of those C8s are gone now. So, anyways, I just want to let you know that things are coming along, and I think our next task will be to look through the observatory, and there's some nice scopes in there as well. So I let everybody know that people that took telescopes with them this go around that basically everything is either evaluation or long-term loan, but at least it's off the site, off of the Sedun site. And if we make it to that point where we might need to liquidate and people don't want some of these things anymore, I'm going to keep maintaining that inventory. And if you ever feel that you can't do without the thing that you borrowed and you would like to acquire it, we're building a liquidation model for that now. So yeah, so for those of you who have taken scopes and you don't really intend on or you intend on adding them to your collection, that's coming up soon. Okay, so I think that's all I've got, unless there are some questions about what has been taking place. I can certainly answer any questions about the collection if people have questions about the collection. No questions?
David, regarding the astronomy day, I don't know if you didn't mention that the movie theater next door is actually got quite a lineup of movies.
Oh, that absolutely. You mean at Astronomy Day?
Yeah, for Astronomy Day, special Astronomy
Yes,
Day.
yes, yes. I was. I went to volunteer this morning at the Wildlife Photographer of the Year, failing to remember. Lauri and I talked about this. I said the exhibition's almost over, so I go down there, and I thought, why are the people not opening up the gates to that? And then I peered in, and I could see tarps were over everything, and I thought, oh, I guess the exhibition's over. Anyways, I called Lauri and I said, Lauri, is there anything I can do? I'm here anyways. And I said, oh, maybe I'll go to one of the IMAX presentations. So as a volunteer, we get in free anyways. So I watched a video, and what came up was a big ad for all these astronomy event things. So they're coming up, and not only that, Project Hail Mary is coming up in May, early May. So if you want to see that on the big screen, and I'll tell you, I've already seen it, and it's it's very mind changing in the sense that it's not it's not a cinematic cliche I could do. Well, there's some pieces that are, but I'll tell you that the reimagining of space and what aliens are and spacecraft, you'll be amazed. It's quite different, actually. I was telling this to Reg this afternoon. But anyways, that's coming up. That will be on IMAX. Dave, you have a question?
Yeah, I was just curious if you know of a company. I know there's a company that you can get fittings custom made to go from one type of fitting to another.
Oh yeah, we've used them before. Reg, what's the name of that place?
Precision Parts.
Precision Parts, yes.
There you go. Yeah.
Myself. But is there something like that for all those tripods? Because some of those Celestron tripods are really sturdy.
Oh, absolutely, and people have already made dibs on them. There's not many of them left, but yes, you're absolutely right. And with shipping costs for things that are heavy right now, you'd be silly not to look at these because you'd save the shipping costs. Absolutely, right?
I wonder if they have like conversion things so you can convert a Celestron tripod to work.
Yeah, they do actually, and I've got a number of things. I have some things from Stellar View, which you can. I mean, they make it for their own tripod, but they have numerous adapters to fit them to Celestron tripods, Meade tripods, you name it.
Yeah,
they've got them. Yeah,
No one
absolutely.
should be buying tripods until we get rid of them.
Probably not until we get rid of them. I mean, there's some there are some that are quite damaged, but there were a lot that were still in really good condition where the mount was wrecked, but the legs were still good.
Yeah.
So yeah, for sure. Yeah, for sure. And Vince, I think you went home with some treasures that you're gonna restore.
No Vince here today, but
Oh
yeah,
no, Vince. Okay. Yeah, he certainly did.
truckloads.
Yeah, he
Two
certainly did.
truckloads.
He's
Two
probably
truckloads.
exhausted. Yes. Yeah.
Absolutely. Hey, Brock, do you have any comments about the what I'm calling the excavation?
Nothing that I can think of. But.
Yeah. Okay.
I do have a announcement on a SIG. The astrophotography SIG is this Wednesday, though.
Right.
So
Right.
anyone interested?
Okay. Communicate with David if you are. Yeah. No, that's great. Yeah. So I think that's all I've got, Peter. Unless people have questions about Astronomy Day or the inventory at Sid's place.
Okay, anyone have those questions? Did my screen go full screen yet?
Yeah, I
Yeah.
see a whole bunch of telescopes. Oh,
Yeah.
I'm having PTSD, Peter.
Yeah, your photo of Sid's garage made me want to share this picture. This is a shop down in Tucson called Stellar Vision. I don't know if you've if any of you have ever been there or even heard of it, but this is their showroom.
Oh, wow.
They basically deal with used telescopes. You can drop your telescope off on a
Oh,
consignment basis.
wow.
Doesn't look
Some
like
re-
so many.
some real classics there, and also some homemade stuff, huh?
Yeah, I mean that's only
Yeah.
one photo. I mean,
Do they actually sell any? It doesn't look that way.
well, yeah, they had a lot of dust on them. It's true, but they were very friendly, and apparently they make their business model on selling domes. And this is
Oh,
basically just sort of almost a side gig for them. They've got all kind of racks of parts and things in the
yeah.
corners and so on. But yeah, I mean, Sid's garage really wasn't the worst thing you could possibly imagine trying to clear out.
No, it wasn't. In fact, it turned out to be quite a history of the Victoria Centre as well. There
Yeah.
were things from George Ball there, and in fact, I'm so glad that Alex took George's refractor and his equatorial mount. It was definitely a thing of beauty. I mean, you can't throw that away.
Okay. Well, thank you again. Um, I usually when I sit in on the Astro Cafes, they always go basically a full 2 hours. Are we planning for the same sort of thing here? Was I correct in that?
Yeah, stop by 5 minutes too.
Okay, all right, no problem. So I figured that we'd have no problem having plenty to say here. I seem to have lost my little slide where.
And
Okay.
Peter, I'll have a short announcement as well.
Oh, well, go ahead and do that now then.
Oh, okay. Okie dokie. I just have to share here. Okay, get out your crying towels. Someone else is sharing.
Oh, sorry, I have to stop sharing. Yeah. Okay, go ahead.
Here we go. Okay, so can you see that?
Nothing.
Not yet. Yeah, there it goes.
Okay, good.
Yes.
So this was the weekend we put my scopes together up in my new observatory.
Yay!
Yay! And the 20 inches up and running beautifully. Everything works slick as a whistle. The observatory is about 99%, 95% there. Here's the 25-inch mirror, and this is it packed all in a nice secure little box.
Wait for
And
it.
here it is, very dusty after its trip from Arizona.
Yeah.
Okay, and you can see a little, I don't know if you can see my cursor, but you can see a little line right here.
Oh no!
Oh,
And here it is cleaned.
No, not
I'm
covered.
cleaning it. And when we picked it up to put it in, here's what happened.
Oh no.
Oh.
Wow.
Yeah, people are turning their eyes away.
Yeah.
Yes, exactly. That's how I felt about it when I saw it
Yeah.
happen. Like, holy smokes.
Oh, Garry.
I agree. I figured as my astronomy family, I should share this with you. You know,
Oh.
I'm quite
Well,
dismayed about it.
you now
That's
have
gonna
as many
take at
mirrors
least
as the Large Binocular Telescope.
Yes.
that's gonna take at least 10 boxes of crazy glue.
Yeah, exactly. I wish it would, but no.
Wow.
Apparently, in transit, it split clean in half, and when we moved it, the two pieces just came apart. So I'll be talking to my insurance company, and I hope they decide to pay for another one. I'm
So
gonna buy. I have to get done.
Gary, was it? Do you think it was broken in transit
I
from
think so.
Arizona?
Yeah. Yeah, I
Okay.
think it was. Yeah, but a very fine crack. I couldn't see it when it was still dusty. Only when I cleaned it did I go, oh my goodness, look what happened.
Oh.
So there you go. Sigh. I'm going to set up a what is it? GoFundMe page. I'm just kidding. But I'll have to buy a new mirror one way or the other because what's a good telescope? What is a big telescope worth with no mirror in it? Like not too much. So there you go.
So is that the 20-inch or the 25-inch?
This is the 25-inch.
Oh, okay.
I use the 20-inch the most, so I still get to do not 95% of the stuff that I was doing before, but I was going to be using this for a lot of community outreach, so this will probably take about a year to get a mirror and get it done.
Do you think you'll get one the same size or?
Oh, I have to. Yeah, I will. Yeah.
Oh, okay.
This is something called a plate mirror. Big mirrors like this are not made out of one piece of glass. They're made out of multiple plates, and they tend to be a little fragile. I found out the hard way. But okay, everything's good. And by the way, for Gil, are you still there? Our speaker?
Yes, I am.
Okay, in the winters, I used to live about 20 miles north of Tombstone. I could see your observatory every day.
You know exactly where it's at.
That's exactly where it's at. So
Cool.
it was delightful to see it. So there you go. So there you go. There you go, astronomy family. I just had to share that with you. And donations are gratefully received. I'm just kidding. Just kidding.
Wow.
Wow, that's right.
Well, I have to stop crying before I continue on now, Gary.
That's why I said get your crying towels out.
Yeah. So let's see if I can go back to where I was. Did it come up? There we go. Full screen.
Yes.
All right, excellent. So I thought I would just give you folks who are in Victoria a chance to just hear a word or two about our observatory here in London, Ontario, on the campus of Western University. It's called the Hume Cronyn Memorial Observatory. It's It's named after Hume Blake Cronyn, who was a Londoner in the I meant to change that. It should be 1864, and I caught that mistake earlier and forgot to change it. So in the late part of the latter part of the 19th century and into the early part of the first of the 20th century, and so of course, he passed away in 1933, and our observatory wasn't built until 1940. So the person who really kind of was spearheading it was our astronomer here in London, who was H.R. Kingston. And H.R. Kingston came to London from Kingston, where he grew up, from Queen's U, and then from U of Chicago, where he got his PhD. Then he was in Winnipeg for a few years, and then got the job in London in 1921-ish. And so he wasn't actually a Western alumnus, but he was made a honorary member years later because he contributed quite a bit to the university over and above astronomy. He was actually a math teacher, and his professional expertise was in math education. But he was keen on astronomy and used his university affiliation to bring astronomy to London, basically, among which he was the founder of the London Centre, the RASC, back in 1922. This is an aerial view of our university campus around 1930. The campus was occupied in 1923, even though Western had already been in existence something like 40 some years before then, but it had been housed in, haphazard buildings downtown until then. This kind of lovely campus is where Western gets its worldwide reputation. You can see that the campus It doesn't have very many buildings in those days. On the left-hand side is the football stadium. At the back there, the structure in the rear left is Brescia College. I don't know when that building was built, but where the observatory ended up is right there. So off to the side, and of course that's important when you think about location of things. And so Professor Kingston was here in London starting in the 1920-ish, and he was here for 15, 16, 17 years without really having much in the way of astronomy equipment at the university. This telescope was donated in 1938, and you can see it says there in the red oval, the university had but meager astronomical equipment. Well, by 1938, obviously that was about to change. So the telescope was ordered in late 1939. They spent 1939 thinking about what to do, which kind of telescope to buy, and so on. And this is what they decided on: a 25 centimeter refractor. At some point, I'd like to boast about the fact that since Ottawa, the Dominion Observatory has a larger refractor, but it's been packed up and it's in storage now. It's not being used. So I claim that Western's 25 centimeter refractor is the largest refractor in Canada. If anyone knows of a larger one, I don't mind hearing about it, but I've been telling crowds at the campus that this is the largest working refractor in Canada. And overall, building
$7,000 in 1938 worth today.
Yeah, I didn't bother making that calculation of how much it's worth today. I always think that those are
$7,000 in 1938.
kind of silly to do that because we all know it's worth more. But anyway, where did we get the money? The money came from a donation. At that time, the university also had a reputation for being a fun place to be. Instead of a university with a golf club,
how much is $7,000 in 1938?
We talked about ourselves being a golf club that happens to have a university with it. Anyway, where the observatory got located is with the green circle here. Where'd the green circle go? Oh, I guess I took the green circle. That's the university. That's the university, the observatory there, that little square. You'll notice it's behind the stadium, and it was actually up on a bit of a hill as well. Oh, there it comes. All right, and in 1939, so right around the time they were planning this, we had the rather interesting event of the Dresden meteorite falling. And this, was a great thing all by itself. I think still to this day, it's the second or third largest meteorite that's been recovered after being witnessed it falling in Canada. And so at the time, I don't think anybody really realized, I haven't read any comments about this, but having the Dresden meteorite in the news probably helped raise the awareness of astronomy in the London community just around the time that the observatory was being ordered and under construction. Here it is in April of 1940 being built. The style is called Collegiate Gothic, and the architect was a London architect named Oliver Roy Moore. It's consistent with the other campus buildings at the time, but you will notice, of course, that there's nothing around it. In this picture is looking towards the observatory, and behind the observatory is the hill that leads down to the stadium. And that's downtown London over to the right there. It had a couple of tall buildings, but nothing really spectacular in those days. You'll also notice that the window on the lower left is below the window that's on the other side, symmetrical with the door. It turns out that the person who donated the money didn't like that. David, I see your hands up. Do you want to ask now or do you want to wait till later? Are you there, David? Or did I end up?
He's muted.
Yep, sorry, I'm trying to find him so I can unmute him.
Sorry, that was an old question, but now
oh, sorry, okay.
You,
okay, no problem.
It's interesting that this took place during wartime.
Yes, of course. I mean, yeah, the plan, of course, was started before the war started, and then it just kept rolling. So yeah, that is, and it's not irrelevant because they made some decisions about things as they go on. Here's what the campus, what the observatory looked like soon after it was completed with the dome open, late afternoon based on the sun shadows. And I like to say the observatory ruled the campus because there were no other buildings around it at the time. The big buildings were a couple hundred meters over to the left in this picture. But Mrs. Cronyn, who was the widow of Hume Blake Cronyn and donated the money in his memory, she did not like the way that lower left window was. And you'll notice over here, the window's been changed. They actually dug it out and rebuilt it so it matched the height level of the other window on the other side to keep the symmetry of the front of the building, which I thought was pretty neat. Here's the dedication ceremony on opening day in 1940. Quite a good crowd turned out. This is on the front lawn. So in the direction we're looking here, there, of course, there are now all buildings. But in those days, nothing around. And I thought you'd all like to know that the Victoria Centre president, Robert Peters, is listed among the folks who sent telegrams congratulating Western on the opening of the Cronyn Observatory. Here's the inside of the foyer in the evening on that opening day. On the left is Mrs. Cronyn coming in, and on the right is her society friend, Mrs. Dunlop, who donated the money for the David Dunlop Observatory in Toronto, which of course I don't know how you folks who actually live in Victoria feel about it, but of course it is just a tiny bit larger than the telescope at the DAO. Here's a couple of other quick facts about the early part of the observatory. There's the lovely scroll work over the main door. It says 1939, even though the main construction and the dedication took place in 1940. We still have the guest book. In fact, I hope we have every guest book since day one. There's about a dozen of them there in the observatory. I don't know when the bronze plaque was put in there. It wasn't on the observatory. Where it's located, the plaque is on the wall next to where you saw Mrs. Cronyn and Mrs. Dunlop coming in there on the opening day. Here's what the telescope looked like inside. There's Professor Kingston on the stairs. And the other fellow there is William Colgrove, who was a volunteer at the university, but a big science person. I've got a couple of his other projects there. The 25 centimeter refractor is from Perkin Elmer down in the US. Remember that the war hadn't started for the folks in the US yet in 1940. There's a Schmidt camera attached on the opposite side of the big tube where you see Mr. Colgrove standing at the top of the stairs. And basically everything that's in this photo is still there today, plus we've added a few other things as well. The observatory did have some other small telescopes that were donated. I think we've lost most of them. I don't know where they all are, but obviously outreach was a big factor back then. We didn't have an astronomy degree program. Mr. Colgrove was a bit of a model maker and a tinkerer, and he made lots of cool models that we still have some of these today. We still show them when folks come to the observatory. We also had a librarian at Western whose name was Beatrice Welling. She collected a bunch of poems and turned them into a cosmic calendar and submitted them to Professor Kingston, basically just to honor the opening of the observatory, but it was a couple years later, actually. And more recently, our club president, past president now, Mark Tovey, turned that into a book and mixed it with some artwork. And that the book, as far as I know, is not available right now, but we'd love to get it up and running again. So the observatory basically did what I was just describing and worked for outreach and so on. No research was done until the 1950s when Professor Waylau came to London. And he was studying Delta Scuti type stars was his primary interest research area. And he wanted to do photometry. And of course, those days, photometry was a little different. They had to use actual little tubes to collect the light. And so an extra telescope was added to the side of the refractor. The big tube on top there is a Cassegrain reflector with the photometer built in. This is what it looked like in 1968, but it was already working a few years before that. And once again, almost everything in the photograph is there today. The only thing that's been removed is the photometer itself. The Cassegrain telescope is still there, and the Schmidt camera is on the other side as well. Neither of them are in common use. Only the refractors in use, but all the mounting and so on, the motor in the drive in the telescope is still there. Everything's still there. At Cronyn, they also fostered the development of a couple other telescopes. This is a 15 centimeter, which has now been dismantled, unfortunately, on the Natural Science Center. They're going to demolish the Natural Science Center soon, so it had to be taken down. And of course, the Elginfield Observatory, which is a 1.2 meter telescope, which is well outside of London. But all of the technical support work was still done. The machine shop and electronic development, so on, was still done in the workshop at the Cronyn Observatory back in those days. One of the famous things that Cronyn is known for in the London community is that the engineering students pull a prank every year. The way the campus developed, the engineering buildings are right next to the Cronyn now, where all that empty space was before is now all engineering buildings. And I'll show you that in a minute. In 1996, they renovated the building. The offices on the main floor were replaced with a classroom, and the basement was turned into, was broken down into different workshops and offices, and earlier even than that. So 1996 was the last major cosmetic change. This is what the telescope looked like in 2015. It still had the orange paint job that, as far as I know, goes all the way back to the 1940s. But we did paint it in 2015. We painted the main tube purple, the University of Western Ontario's colors, for our 75th anniversary. And we've had a number of big events. This is what the observatory basically looks like from the front today, although the trees, the landscaping changes every few years, and it's kind of sobering for me to think that I've actually been at Western long enough that I've seen trees grow from being small trees to being large trees and then being taken down and replaced in my time there. This was our 75th anniversary. That's what the classroom looks like today. Our university president was there to offer some congratulations. It was a rare thing to get him in there. In recent years, our current director is Professor Kami in the astronomy department. Here he is standing under the telescope with David Levy when David visited a few years ago. And one of the clever things that Professor Kami did was he built basically a giant plastic bag to put over the observatory and make it look like R2-D2. They did that on purpose. It was a stunt, not a prank. And I don't know if they've kept it. They only ever did it once. Just to round things out, just to show you, give you an idea of how bad things have gotten on campus. This is the campus in 1955. The stadium's visible just above the center. And that's where the Cronyn was. You can't even make it out really in the aerial photo. Downtown London was this way, but still about, maybe 6 kilometers away. So it was far enough away. So you had pretty much unobstructed views at that time in 1955. Now the red rectangle is going to be expanded in the next slide. So watch, the next slide shows, this is the present day view that you get from Google Earth of what that red rectangle looks like. And you can see that there is no space around the Cronyn Observatory really at all. The Alumni Hall is the big concert hall and basketball venue. The Western Law buildings over there and all those other buildings are engineering. And in fact, so there's Cronyn there hidden behind that little camera icon. And the old stadium was there, and that was what the orientation in the previous slide. And now here's the really bad news, almost as sad as Garry's mirror breaking. There is a new engineering building being built right now, and it's going to be 6 stories tall, 3 stories which will be above the Cronyn Observatory. So we're going to lose our eastern sky completely in the future. So we really have no sky left except directly above the observatory. It's really all we get to see. When the planets are visible in the south, it's okay, but really we got no chance to get things near the horizon. And this is what the back of the observatory looks like today. This was an event in 2015. That is one of the engineering buildings to the left. The parking lot that's on the right has now been taken over and is now a job site. Crazy. Well, we're moving on to the future. And I guess I did take a little bit longer than I was supposed to because it's only 1 minute to, and you asked me to stop at 5:02. But there we go, folks. And thank you for letting me be your host tonight. And I hope you enjoyed what we did. Thank you.
Very good. Thank you so much, Peter. You did a wonderful job.
Thank you. Do we need to wrap anything up, or I guess you have control of it. I don't have to push anything to close us off, right?
Yeah, no, but
thank you all for participating.
I will be the host next week, and we will certainly be talking GA, but register for the GA.
Right.
For the General Assembly at the RASC site. And we'll talk more about it next week. And see you on Saturday, everybody.
Good night, everyone.
Bye.